Hey class, Mr. Moynihan here with a couple of examples very similar to your homework on chords and radii and diameter and the relationships therein. So let's take a look. The first question asks us to find the value of x. Actually, all of these do. So we're going to do several of these. You'll notice that x is a diameter, and we don't really have much to go on until you realize that this length right here in total in red is a radius, right? Because it goes from the center all the way to the edge. So if I can find the length of the radius, which in this case would be the sum of these two lengths, 13.6, then I have the means by which I can find the diameter. So this red length is 13.6, which means the diameter then would simply be twice that, because that's the radius. So that would be 27.2. And that's really all there is to it. It's recognizing what's given to you and then doing something with it. That is harder than it sounds, though. Let's take a look at the next one. Once again, looking for a diameter. Hopefully you can see that all you got to do is find this radius length. So that would be 9.4 plus 10.6. That's the red length. So the total diameter here would be 40. Moving along, they started off kind of easy. They're going to become a bit more complicated. So here we're given several chords, a chord and then a couple radii, looks like. So the question is, what is this length right here? It's not very clearly marked, but that's the length we're looking for. Well, hopefully you realize that this is a radius right here, and conveniently it actually makes a nice little right triangle already. So all we got to do is use a Pythagorean theorem. So that would be, 8.3 is one of our legs, squared, is this, plus x squared, which is the unknown length, is going to equal the blue length, the hypotenuse, which is 22.2 squared. So with a little bit of calculation, we can find the value of x. So bear with me a moment. I'm going to zoom out a bit. We have 8.3 squared, which is that number, 22.2 squared, which is that number. I'm going to subtract this from this, so minus this quantity. So that means that x squared is 423.95, which means we're one step away from finding just x. Take the square root, and thus x is this value right here. Oops. Square root of the answer will give me 20.6 approximately. And there we have it. So part of the challenge here is recognizing when to use which particular skill, and that takes a little bit of trial and error, but some practice here hopefully will help you become more proficient at that. Here we're given a very similar shape in some regards. We're asked to find this length right here. It's once again not very clear because of the software. Nevertheless, all we've got to do is to recognize that that length is going to be found using the Pythagorean theorem, because if this blue length right here is a radius, 15.6, all radii in a given circle are congruent, so this is also going to be 15.6, and once again, we have a very similar problem to the one before. So I'm not actually going to work this one out, but hopefully you can realize that you can carry this distance here because they're both radii, and then it's very much like this problem right over here. For the last two in our set here, we're asked to find parts of radii. That requires a little more nuance once again. Let's take a look at this first one. Excuse me. This radius length of 16.7 is not very useful where it is. So I'm actually going to basically rotate it along the circle until it becomes this length here. So these are both radii, center to edges. So this would also be 16.7. I'm given this 15, which represents this length right here. And what I'm looking for is not really part of that, but if you think about it for a second, if I can find, for lack of a better word, let's call this B. If I can find B right here, do you see how that will help me find X? Because I know that in total, this length right here is also 16.7, because all three of these are radii. So if I can find B, I simply take that away from 16.7, and I will have X. So once again, using the Pythagorean theorem here, this would be 15 squared plus b squared equals 16.7 squared. So let me show you a little shortcut in the calculator. What you can do is recognize it's going to be the square root of 16.7 squared minus 15 squared, and right away we'll get 7.34. So this length right here is 7.34. So that's not x, but it's pretty much giving us x because we know that this whole length here, as mentioned, is 16.7. So simply take away from 16.7, 7.34, and we have a final answer of approximately 9.44x. So a lot of moving parts there, but if you take them each step by step, you'll see it's not too bad. This problem here, once again, is very similar. We're not going to work it out in depth, but all you got to do is carry the radius length around the circle so that it's here. So that would also be 16.8. Use the Pythagorean theorem of these to find this length. Remove that length from this third radius, which is also 16.8, and you will find x. So hopefully this gives you a glimpse of what to look for and what to do when you've spotted certain situations. All right, see you in class.